Hi everyone, I am going to solve this system here using Gaussian elimination. So the first thing that I'm going to do is write down the augmented matrix that corresponds to the system. There's a row for each equation, and I end up with this matrix right here. So the idea is to use row operations to transform this matrix into diagonal form. And let me just jot down here to remind you what diagonal form looks like. It's going to have ones on the diagonal and zeros off. And then there's some numbers over there to the right, and that of course is going to be my solution. So let me start the row operations. I have in this position right now a 2, and I need it to be a 1. 1/2 row 1 is going to change that into a 1. Multiply everything across the top row by 1/2. And the second row stays the same. Now in this position I have a 5. And I want to add a -5 to that in order to make it a 0. So I'm going to take row 2 plus -5 times row 1. 1, 3, -3 is the top row, and the new second row becomes -5 times 1 plus 5, that gives me 0. -5 times 3 is -15 plus 7 gives me -8. -5 times -3 is 15 plus 1, 16. Now, in this position, I have a -8, and I would like it to be a 1 in that position. So, -1/8 row 2 is the operation that'll do that. Across the second row, I'm going to multiply by -1/8 times 0 times -8, that gives me +1. And 16 times -1/8 is -2. Now I have to go to this position and make a 0 there. So I'm going to take row 1 and add to it -3 times row 2. So going across row 2, I take -3 times 0 and add 1, -3 times 1 and add 3, -3 times -2, that's +6, and -3 gives me 3. And here I see my solution sitting right there. X equals 3, y equals -2, and I can write it as an ordered pair, 3, -2. If I substitute that point back into my equations, it will satisfy both of them.